Okay, so this is going to be a video on my particle photon controlled RC car. This is a school project that I put together. And it turned out pretty well, but I had to do a video here just on how it went together, um, how it works, and what all I had to do to get this thing working right. But basically, this car started out as a car that I picked up from a hobby shop while I was visiting some family out of town. So this is basically what this guy was before I started messing with it. So it is, or well, it was radio controlled, and it came with the little remote steering wheel and throttle. And getting everything up and going wasn't all that difficult. But how I did it basically was, the first thing I did was disassembled the car. And one interesting thing about this, I didn't necessarily know this when I was looking at it to buy it, but it actually has Phillips head screws just about everywhere. So you can remove all these body panels. Then there is a plastic, roll cage underneath, and then you can remove that pretty easily as well. But basically, that's what I did. So got all the body panels off, got the roll cage off, and then there was basically got down to the chassis on the car, and there was a sealed lid on this guy, and underneath that was the board that controlled the car originally, when it was radio controlled. And that guy is right here. And this really was pretty simple. And I imagine I could have made this card where it was also RC controlled and IOT controlled. But this guy just had a plug for the drive motor, forward and backwards. Then it had another one for the steering motor, right and left, and basically a radio antenna. And that's really all there was to it. There's also power to the board back here. So that's your plus power. And there was a ground right there. And it is a little bit more complex underneath. I couldn't really tell you what any of those are, but basically all there were was 6 wires, 2 for the drive motor, 2 for the steering motor, power and ground that came off of a on-off switch that was under the car. So that's right there. And from there, basically the way I approached this was the same way that you would control any other DC motor with an Arduino, and that was with a DC electric motor controller. And the one I use is referred to as an L298N dual H bridge. There are a lot of different variants of it. I actually used the slightly different version than normal. Mine actually has an extra row of control pins, I guess you could call it, those 6 exposed male pins down there. But once I had my 6 wires run up from the case, so 2 wires for the drive motor, 2 wires for the steering motor, 2 wires for power and ground, I mounted my DC motor controller just to the top of that. And from there, I mounted the Photon on the back here. The spare tire was originally back here. So I used double-sided tape, put the breadboard back here. There's also double-sided tape holding down the motor controller. And I ran wires from the output pins, I guess you could call them, the control pins on the DC motor controller back here to my Photon. And then there's power and ground, 5 volt, going to the Photon as well. And really, this was the only difficult part. The difficult part was figuring out how to use those 6 pins right down there to control the car. So how this ended up working, I actually have a little circuit diagram that I made in Fritzing, was you have the power, like I mentioned before, the 6 wires. So 2 for power, this is switched, 2 for the steering motor, 2 for the drive motor, and those just tie in here on the DC motor controller. They are, see, they're little screw-in stabs. I believe they're Phillips head. Yeah. But once you have that, and you have power to the Photon, which it uses the same ground as the switch power does, but there's also a 5 volt pin, this third lug here, that goes back to the Photon. So this is my ground here, and it goes to that same ground right there. And then you have the VN pin on this side of the board, and then that goes right back to that plus 5 volt there. And this will probably make a little bit more sense if you're watching this and you already have a Photon, you're looking to do something with it, and you're already a little bit familiar with it. So once you have all that stuff out of the way, you have the wires run, you just have to get the logic down. Basically, what you're going to be looking at is just these 6 pins right here. So let me hold on 1 second here. Okay. So you have these 6 pins here, and really what this DC motor controller lets you do is it lets you drive 2 separate DC motor controllers. You can drive them forwards and backwards, or you can reverse the rotation forward and backwards independently of each other. And then you can also control their speed, and you do that by using your enable pins here as basically pulsed outputs. You use pulse width modulation to vary these, and you can even control the speed of both of these guys. So you have 6 pins here. You have an enable A, enable B, then you have an IN1, an IN2, an IN3, and an IN4. So this is the part that I guess gave me the most trouble out of anything, honestly. Believe it or not, there really weren't too many stumbling blocks with this thing. But basically how this works, let's look at the drive motor, for example. So how this is going to work is you have your enable pin. If you want to use the drive motor, you always have to have the enable A pin on. This is kind of like a kill switch. So if you want to turn your drive motor forward, you have to have your enable A pin on, then you have to have your IN1 pin set to high and your IN2 pin set to low. So if you want to go forward, have to do this sequence right here. And then, of course, these 3 pins just go to 3 digital outputs on the Photon. That's D0, D1 pin, and D2 pin. So with ENA high, that's always high if you want to do anything. IN1 high and IN2 low, that gives you forward motion. If you want to go backwards, all you have to do is set IN1 low and IN2 high. Okay, still keeping that ENA pin hot, just to let you do anything. Then you have the mirror image on the other side. So you have your enable B pin right here in the yellow. If you want to do anything with the steering motor, that guy has to be hot. So you have your enable B pin on, and if you set your IN3 pin to hot and then your IN4 pin to low, then that will make you steer to the right. If you have your enable B pin on, your enable 3 pin low, and your enable 4 pin high, you're going to end up going to the left. And so these 3 pins right here, these 3 pins from the DC motor controller, they go to, again, the same side of the Photon, but this is your enable B pin on D3. Then the red pin there, or the red wire, that's coming from your IN4. Yes, IN4. That is going to, that'll be the D4 pin, and then IN3 to D5. So once you have these combinations of the all the IN pins figured out with the enable pins, you can then go over to the Photon and figure out how you want to control it from there. So basically, if you want to go forward, you have these set of commands. Effectively, if you want to go in reverse, you have these sets of commands: right, this, then left, that. So from here, what I used was something called the Blink app, and I'll roll in photos here of that. Inching the car forward and backwards, left and right with that. But basically how that works is it is an expanded version of the Tinker app that you, if you have a Photon, if you set it up already, you'll definitely know what the Tinker app is. So the Tinker app basically just lets you test outputs on your Photon via your phone, and Blink does that in the same way basically. So once you have Blink on your phone, you can open it up and configure buttons to do certain things on your Photon. So on my phone right now, in the app currently, I have the D1 pin on the Photon set as a button. So this is a momentary switch, and it defaults to low. If I press it on my phone, it goes to high. And what that results in is, in this case, I have my ENA pin. I don't have the icon shown here, but that is my pulse width modulated output. So that's on the DO pin down here. That DO pin is set on a slider in the app. So that is scaled from 0 to 255. So that guy is effectively always on. But since all these buttons default to the low state, as soon as I press this D1 button, it sends the command to my Photon and turns that D1 pin high. And since the D2 pin is default to low, I end up making the car go forward. And as soon as I let off this button, the car stops. And it's the same thing for reverse. All the pins default to low with this button configuration. So when I hit this button, the reverse button, that D2 pin goes high, the D1 pin defaults to low, and the car goes in reverse. And it's the same case with the steering. So right and left, you'll have that same pattern. And this is really all there is to the mechanics of how this guy works. Really not any different from controlling any other DC motor with an Arduino, honestly. I just want to do this video and maybe make it a little bit more clear on some of the directions. But really, it wasn't as difficult, or nearly as difficult as I thought it would be. I didn't really have to use any transistors, resistors, diodes, anything like that to get this guy going. There are plenty of other, DC motor controllers that somebody could have used. They wanted to do this project, but overall it wasn't that bad. The car performs really well. So with that Blink app, there is, I guess you could think of it as a command interval, something like that. So basically, the app has a response time somewhere around 100 milliseconds. So you really can inch the car forwards and backwards. I wasn't expecting that to end up with that kind of performance. I really thought that there would be a very big delay in between when I hit the command on the Blink app on my phone and when the car actually, responded. But it drives really well. You can slide around, do all sorts of cool stuff with it. But really, there wasn't a whole lot of performance that I gave up by going to this setup. And of course, I wasn't expecting that. That wasn't what this was supposed to be. I just wanted to see if I could do it. But it ended up working out great. You can really drive it as hard as you want to, not have to worry about the app being too slow, the interface being too slow to keep up with the car and all that. Trying to think of anything else that I want to show here that I did. Already mentioned the DC motor controller down there. I actually picked this up at that hobby shop too, believe it or not. I was really surprised when they had this. They had this in their little Arduino kit section. I was expecting to have to order something offline, but I was out and about and I saw it and I thought I might as well make it work. But this is actually a slightly off-brand version. I believe I mentioned that before. Wiring on the Photon. I had a pretty big strip of male to female breadboard pins, so I just left them bonded together, and then I used some heat shrink that I had laying around. I used a bunch of different sections to kind of give it some flexibility. But pretty much just ran those to the breadboard, and then they all push down pretty good on the pins. They have really good retention so far. I haven't messed it up. I haven't had any issues with them coming out, anything like that. But in terms of this project, basically, if you wanted to replicate it to, with any other RC car, the Photon's $19, and the motor controller I got was like $9. You can probably get one for under $5 somewhere online. Really not all that expensive. I had the wire, the heat shrink, all that. And then my Photon actually came in a maker kit, so it had all the breadboard jumpers and stuff like that. But I'll roll in some video here with the car driving around, sliding around, doing all that. And I'll probably end up doing another video here there's actually another component to this project, and that's another photon that has to end up communicating with this one. It's a project requirement. So I'll do a video on that, but there's a lot to cover here, so I thought I'd do one just on I guess the mechanics of how the car works, and then do another one on getting the two photons to communicate with one another. I'm actually going to end up installing headlights, or well, not headlights, they're going to be turn signals in the front and the rear. So I'll effectively have one photon communicate with another over the internet. When this photon commands the car to turn right, the other photon is going to pick up on that command and then fire the turn signals depending on the direction. So I'll include that too in another video. Okay, so this is going to be part 2 of this video. Originally I didn't plan on doing this, but I thought it would show sort of the progression of the car. So one thing that I believe I mentioned in the previous part was that this is actually a two-person project. So second part of this project, once I got the car going, essentially was incorporating another photon. So this is actually my partner's photon back here on the car. It's mounted just behind mine. And basically the requirement for the second photon in this project, or where it fits into ours at least, is to have variable communication between the two. So currently this photon is receiving a command from my photon over the internet to fire these two LEDs. So you see the blue one right there, and down here you see the clear LED. That guy's actually yellow. So essentially right now what this guy does is when I hit left here on the blink app, and let me move the phone down here. When I hit left on the blink app, it gives me a left turn signal, and then a right gives me a right turn signal. And the only two wires between these are ground and then power. So this is occurring over the internet at a pretty good speed. And I will go into essentially the code behind all this in the next video, and I want to go through it in detail and also go through the Blink app, which you haven't seen necessarily before this video. I mentioned it in the previous part, but I want to go through that in detail, especially now that I understand a little bit more how it works code-wise, and I want to clarify how it relates to the code that's actually running on the Photon. How do you blend the two together? How do you keep functionality on the Blink app and then still have both your photons, or either one of them, or whatever, still running their own code and doing whatever you want them to do. One thing I did forget to mention in my previous video, I actually made a mistake on the wiring, and you might have caught this. Let's see, right here. So I did get a wire mixed up, unfortunately. So if you look right here, this black wire right there, that black wire should be going where this red wire is currently. So that's the IN, coming from the IN3 pin on the motor driver. That should be going to pin D4, not D5. But that's the only correction I thought I'd want to make. Not too bad. Other thing, again, there's a third part coming to this video, but you can check the link in the description below for the Hackster. A link to this guy, so you can find all the code, pieces, parts, everything I used in there. So that'll be all finished up by the time I post this video. and part 3 is coming. Hopefully this video won't be too long, but I wouldn't be surprised if it ended up being somewhere around 45 minutes. It's not the easiest thing to watch, but I wanted to go over everything in detail, just for reference, anybody out there trying to do anything similar. But thanks for watching. Okay, so this is going to be part 3 of this video, with everything wrapped up. So this is the car as it currently stands, and like I mentioned, this is with all the LEDs run. So we got 4 on the left front, 4 on the right front, 4 right rear, and 4 in the left rear. And now we got a whole mess of wires back here. Nothing too complicated. It's just, you know, when you add 16 LEDs to the car, the wiring's going to get kind of busy. So I guess this is going to be kind of the final demonstration for this car, and I'm also going to take some time now to go through the code on the Blink app and how you run the publish and subscribe code in addition to the Blink code. That's not all that bad. A lot more easy than I thought it would be, and my partner helped out a huge deal with that. But I'll go ahead and get into it. So right now we'll go ahead and do the left turn signal. So I'm actually holding it on, but I can do a momentary trigger. So just to show you on the phone, was a minor bug there previously where Blink will stick on, but that is inherent to the app and the network that the car is connected to. It's a bug. Nothing I can really do about it, but again, just a momentary on the left, momentary on the right. And I have the steering scaled down currently, so if I scale that up, you'll see the wheels jerk around there really hard, turn fast. But I keep that guy turned down when I'm just here demonstrating it, because there's no need to jerk the front wheels back and forth like that and put that much more wear on the front end. But that's also one feature that I forgot to mention previously. So up here, labeled as boost controller, I have that scalable from 0 to 255. So if I have boost controller on 0 and I hit forward, nothing happens. But if I have it on, let's say, what is that on now? 163. Let's hit it. Let's turn it up to 255. You can hear the car pick up there. If I turn it down to maybe somewhere around 80 or so, quite a bit slower. So that is one advantage that this has over the RC version, is that you can actually scale the power output. So if you are in a smaller area, like inside, and you want to drive the car around, you can slow it down effectively, so you don't run into stuff, things like that. So there's the wiring and the LEDs. Tried to install as clean as we could, and I think it turned out pretty well. Still have to tidy up the wiring in the back, but that'll come sometime in the future. Probably won't share that in the video. But there it is, and I guess that's really all in the car, or all about the car at this point, all the info that I thought needed to be known. So I guess I'll go into the coding now and talk a little bit about that. Okay. So first, I'm just going to go through the code that allows Blink to run, and there's a lot here, but I just want to go over Blink first and count up how many lines of code it actually takes to get that interface between your phone and the actual Photon. So first couple lines here that define Blink serial. Then you have that hashtag include blink.h, so that is the Blink library. Then under void setup, you have that serial begin 9600, that delay of 5 seconds, then blink dot begin, then in the void loop, you have blink dot run there. So that's 1, 2, 3, 4, 5, and 6. There's actually one more here, this char authentication. I actually blacked this out here because it says kind of private info, but you are going to be given an authentication code on the Blink app as soon as you go to set up your Blink project. And I will go into that in a little bit, but not too much, because if you know how to use a smartphone, you can set up the Blink app. Basically, it's not complicated at all. But really, so let's go back through there again. 7 lines of code. That's all it takes to get full mappable control of your Photon with your smartphone. So that is awesome. The other stuff, the wireless communication that lets my one Photon notify my partner's Photon that I'm turning and I need to turn the turn signals on, that is pretty much the rest of the code. So basically initializing the pins, and then getting down here. So in the void loop, what gets repeated constantly. So if the basically it checks to see if that LED pin D5 is high. If that pin is high, aka turn left, it is going to publish that particle dot publish, and the event is going to be called left, and then the message that it will send is quote NASCAR, and then that is public. And the same thing for the other turn. If D4 is high, it will publish a separate event called right, and then the message is not NASCAR. And that is how this works. And there's some other code in here also that is kind of due to, I guess, how everything ends up working. And that is because, everything happens here so fast. Even if you put your finger on, let's say, the left turn, and you end up having that D5 pin go high. Even though to humans, it seems like, you put your finger on the button and you lift it right off. Well, actually, with how fast all this code runs, your finger was on there for quite some amount of time, so it ends up sending several of these left turn commands. So what you have to do is effectively slow that down. So that's what some of this other code does. You have to end up using a millis function, and you can look this up in other Arduino code of what this does. So you could, in theory, put a delay 500 here. So that would delay half a second, put a half second delay in between when events could be published if you put it right after that particle.publish. What happens there is, because it's inside the void loop, you end up with half a second delay. And remember that blink.run is what it's the key there. That blink.run function is always running. That's what lets you have the communication between the Photon and your phone, and that's what lets you keep that control. So if you put a half second delay here, half second delay here, that's 1 second delay every single time. Well, a continual 1 second delay. So you can imagine how that negatively affects the control from the Blink app to your phone. So by using the millis function, it's effectively a stopwatch, and when it sees the basically the timer count up to 500 or half a second, that's when it allows the Photon, or my Photon, to send the command of turn left or right to my partner's Photon. And I guess to be more accurate, it's not necessarily a command. It's publishing an event to the cloud, and then my partner's Photon subscribes to that event. So publish and subscribe is how I did this. Published an event name with a message, and then again another name with a message. And feel free to look that up in all the particle documentation. But that's how I'm implementing it. That's how we're implementing it in this case. And then you have a couple more variables up here. There's unsigned longs. Those are basically a basis of comparison for the to store the current time for both of those. So now I'm going to go over to the code on my partner's Photon here. And again, you have some of the more administrative stuff up here, initializing all the pins and basically getting everything to start off in the low state, defining everything as outputs. Then here you have the subscribe functions. So it subscribes to the left and the right event that I call on command, and then refers to the response left and the response right, which are the reactions to receiving these events, down here. And for response left, it's going to turn this LED high low with a 100 millisecond delay in there. And again, we aren't running a blink function inside of any of this. We don't have to worry about having a logic delay effectively. We can have a delay in the logic that affects the actual LED, and that's fine. But that's really all there is to it. So again, having the publish and subscribe is the key to this. Other things I'm going to go over very briefly are the Blink app. So I will pull that up here and just go into that a little bit more. And I guess the general process for how you build the app. So what I'm going to do here is go over to actually stop this program here. I'm going to go to the plus there, and effectively you have a balance here, and that balance dictates how many features that you can add to this app. So you have a button here that I could add. Just tap that. And then this button is configurable to a pin on the Photon. So I could set it up to be a digital pin, and I could configure pin D6 to be a switch, like on off or momentary as a push, and I can label it. And that's basically the general sort of workflow of the Blink app. And that's really all there is to this. So get this guy downloaded and go flash. Let me get my pin back here. Kind of messy here, but stick with me. Get those 1, 2, 3, 4. That's the code you're going to get from your app. Again, Blink has more documentation on this, and then there's more documentation for everything else here. If I didn't do a good enough job of explaining that, so get 1, 2, 3, these 3 lines of code, these other 3, and then make sure that blink.run is in your void loop. And that gives you full control over your Photon, and then you can configure everything else on the phone itself. So that's it. Really have enjoyed this project, and I'm going to be looking forward to finding other cool stuff to do with these Photons, and I might look into some of the other boards that the Particle makes. This has been really cool, and I've been so impressed with I guess not only the Photons themselves, the development environment that Particle offers in terms of the the actual build, the console, and the documentation. They're really cool. The response time works very well. Running the Blink app, and then the same thing with the publish and subscribing to the events. It's all around. It's really cool, and it's really awesome to have this kind of capability in a microcontroller and have it not be too difficult to get up and going, and to have all that capability. So this is it. I'll do the LEDs here, the turn signals one last time. Probably would help if I did on the side of the car that you could see, wouldn't it? So, left turn, and right turn, spin that around, left turn, right turn. Right, there you go. Thanks for watching.